Hi friends, this is a simple peak detector circuit. A peak detector is used to capture the highest value of a changing signal. In the circuit, the signal from the function generator goes into the first op amp. This op amp works like a buffer so it does not load the input signal and keeps the waveform strong. After this, the signal goes through a diode. The diode makes sure that the capacitor only charges when the input voltage rises above the stored voltage. Because of this, the capacitor always keeps the highest peak value. The capacitor is the heart of the peak detector. It holds the maximum voltage until you reset it. A small resistor is connected to ground to slowly discharge the capacitor, but only very slowly. You also added a push button that resets the stored peak instantly. When you press it, the capacitor voltage quickly drops to zero so the circuit can detect a new peak from the next part of the waveform. After the capacitor, you have another op amp. This op amp is again used as a buffer. It reads the voltage stored on the capacitor and sends it to the output without loading or disturbing it. This keeps the peak value steady and clean while you observe it on the graph. Because of these parts working together, you can clearly see how the peak jumps up when the input wave reaches a new maximum. On the graph, you will notice that the main waveform keeps rising and falling, but the peak detector output stays at the highest point until a new higher peak appears. This is how real peak detection works in audio circuits, measurement systems, and signal processing. The op amps keep the signal stable, the diode controls the direction of charging, and the capacitor stores the strongest part of the wave. When you press the reset button, the stored value goes back to zero and the circuit starts fresh. This makes it easy to study how signals change over time. The circuit you built is a great learning tool to understand peak storage and signal behavior. Thank you for listening.